Okay, so again, we're just talking the basic chapter 3.9 in the book, and they talk about, of course, basic design for apps. And before we start our main lesson for today, I just wanted to talk a little bit about design and about how apps kind of work and the difference between Android and iOS. And of course, Android's been around for what? 7 years maybe, only. Okay, so we're looking at the Google Play right now. It's just like the iTunes or Apple Store thing, right? So Android, which is larger in the world today, Android or iOS? Android, of course. You know. So Android is much larger, especially around the world. I mean, here maybe a little bit more Apple, but you know, most other countries, Android is very popular. It's only been around for 7 years. Android is kind of based upon Java, and in fact, Oracle has sued Google over Android because Oracle owns Java, and they included a lot of Java into Android. And of course, Google says, well, Java is supposed to be open source now because Oracle says, hey, it's open source now. You can build upon it, and so that's what Google did. Hey, you wrote, hey, we can build upon that. We're going to do it. Why not? And so they, of course, they got lawyers and that never went anywhere. But still, you know, I guess the future really is Android, I think, a lot more than I think Apple. I mean, Apple can continue. They'll still make money. They'll still there. But, you know, I really believe Android. And even though we're learning Apple and we're learning the, you know, iOS, you know, Java, Android-based, it's object-oriented language, the same as the Swift that we're using today. Words are a little bit different. You can download the software and try it. It has a graphical user interface, just like we have here with Xcode, right? It's called Android Studio. It used to be called Eclipse, and they evolved Eclipse into Android Studio. That's what my son was using. He's Android. The class he was taking in high school was Android-based. Many of the high schools would teach, you know, app development using Android because most of the programmers are Java kind of people, that kind of stuff, you know. And Apple's too expensive. Even in the Union School District here that I work closely with, you know, which would be Branham, Lee, whatever, Prospect, Westmont, you know, the ones around this area here, at least that direction, you know, they have basic app development classes. They're all Java-based. Python, they teach us the object-oriented programming. Again, mostly because the teachers there are that kind of teacher, you know. If they're, and Apple, it's a little, of course, they don't want to spend the money to buy an Apple Lab as well. That's the other problem, really. You know, if you look at this, you know, each one of these is probably, you know, almost $3,000 a piece. Whereas they can go and buy a bunch of cheap, you know, Lenovo's or something like that for 1/3 the price, you know. So again, though, Google Play is their store. I used to have a Google device, Android device, but kind of died on me. The Wi-Fi died on me. So one of the things to keep in mind, they do have Google Play is their store. The nice thing about it is they have these color, and if you haven't studied in the interface design class, we talked a lot about material design. And material design is the design philosophy of the Android, and you should study that and look at it and find out how it works. They got a little video here.
Design is more than pushing pixels. It should help solve problems. Design is a way of thinking, an exploration to discover what works best. It requires collaboration with your team and the people you're building for. Design is a shared language, made up of elements that speak to each other clearly and are flexible down to every last detail. Design is never done because we live in an ever-changing world. Material design is a unified system, combining theory, resources, and tools get to the heart of the solution together.
So the material design, of course, is their kind of design philosophy there at Google. It's been around for a while. I think, one of the things that kind of unifies the Android, and I know they have a lot of different products, right? You can buy an Android on, you can buy, where was my Android? They have all the different phones that you can buy, right? And so on. And you got your HTC, you got your Moto X. Anybody have an Android phone? Yeah. You got your Moto X, you got all those different ones. Again, what kind of brings them all together is the material design, and I think that was a good idea for them to kind of put out such a strong design philosophy for their app program or their apps. And a lot of them kind of follow that, and most of the apps look similar, And Apple does the same thing as well. Of course, we have our. I'm missing my. Where is my Apple stuff now? I had Apple Windows open somewhere. I guess I lost them. We can click on our Apple Store again. Again, the Apple has their iOS. And of course, it's evolving and changing all the time, as we know. They have a lot of new features every year that they try and implement. Of course, their augmented reality is what they're trying to push this year, but it's it's still in its infancy. I would say. Of course, their pay and so on, and so on. Again, their design philosophy is the Apple Human Interface Guidelines. Of course, I've shown you this link before, and so you should at least try and follow that and look into it as we go through. That's what this chapter is all about here in the chapter, in the book here. So let's get to the book again. Again, simple workflow, which is lesson 3.9. They basically tried to give you a overview of the iOS, and as you can see, they basically revolves around their UI kit, which is their way, and of course their the UI kit foundation has basic design principles. They have a link right there to the iOS Human Interface Guidelines right there that you can click on, which we're looking at right here. Again, going through and looking at how they use the bars. They have pre-made bars and how to use those. They encourage you, and I think I gave you that video at the beginning of the semester to look at where they encourage you to follow their design. And you don't have to, and in some senses you can deviate a little bit, but the problem, of course, is that some people might need to learn your interface if you deviate a little bit than if you use them. But then you got the other people that say, well, if we just keep following all the Apple pre-made graphics, it's going to be pretty boring, right? So making your own is a little bit more interesting. So, you got your balance between how much do I need to put in of the iOS pre-made graphics and, how things work versus my creative, and it's up to you to try and figure that out, I guess is what I'm trying to say. So here we can put one on one side and one on the other. So again, over there we got the guidelines here, and there's a whole bunch of different guidelines that they talk about. Okay, and you can follow those. In the reading, they talk about all the different aspects there. Aesthetic integrity, consistency, we can turn the page. Direct manipulation. Through direct on-screen content, users can see the immediate visible results. That would be like if you drag the delete for the email, right? Feedback tells the user what's happening as they're going along. In fact, all these principles that they have there, I wrote about in my thesis, was all based upon interface design guidelines back in 1995. I had consistency, and these are the sections of my thesis were direct manipulation, feedback, metaphors, user control. I used the same words. Maybe they stole my thesis for this. Again, the early metaphors that they talk about here, Apple's gotten kind of away from that. If you think about it, the early versions of the Apple were really based upon graphics that look like what it did and less of flat design like Android does, right? Android just does simple shapes, flat design, where Apple always had these kind of metaphor, you know, CD looked like a CD and so on. But they've got it kind of away from that because of the way that you can see it a lot easier. People can interpret graphics a lot, abstract graphics a lot faster and easier than trying to think about what an icon looks like. I thought the best thing about this chapter here, the 3.9, was the end here where they talk about the navigation. Why would I use one over the other, right? On page 391, why would I use a table layout over a tabbed layout over a... and so I thought that was kind of the best part of the reading here. Your job as a developer is to implement navigation in a way that supports the purpose of your app without distracting the user. Navigation should feel natural and familiar and shouldn't dominate the interface or draw focus away from the content. In iOS, there are three main types of navigation: hierarchical, flat, and content-driven or experience-driven in the style user. So the hierarchical is, of course, kind of, where you have kind of the tab menu with a back button and so on. So, you have this sort of flowchart structure, kind of like what we were doing before, where you go from screen to screen. That's where, in web design, we would use our breadcrumbs, right? Remember the breadcrumbs in our web design? Hey, I went from, from main page to tools page to a specific tool and back again, at least from what I was doing. For this style, you'll typically use navigation controllers to enable navigation through a series of hierarchical screens. When a new screen is displayed, a back button on the left end navigation bar easily returns you. So, it's a very quite simple way of going about it. One of the downfalls of that might be if you need to go really deep into content, how deep do you need to go? The next one they talk about, of course, is the flat navigation design. Switch users between multiple contents, like the music app. That would be the tabbed menu. And you'll see that it's more of, the menu is kind of always on the screen, right? The tab menu is always down there. And you just click on what you want. It goes to the screen you want. Much simpler, if you remember from last week when we were doing tab menus, much simpler maybe than the table kind of layout. The downfall is that you're limited by kind of the sections, right? If you have something that has a lot of information, tab menus might not work as well as the table menu. Because I know you can have a little more button for the tab, but that was kind of distracting, right? Remember they said, hey, put 5 at the most, right? Last week, if you remember, 5 was the most. And then, of course, the last one would be the content-driven, experience-driven navigation. Of course, this was more of a kind of a game, maybe, kind of navigation, where the user kind of flows through. You might need to jump around, but you're basically flowing through from one screen to the other, to the other, to the other. Could be a game kind of navigation. So depending on what kind of content you are making will depend upon the type of design that you're kind of talking about in this chapter 3.9. Then they kind of say on page 391 that it's best probably to use the pre-made graphics and so on so that people understand, the bars, views, all very similar. Then again, they talk a little bit about example workflow if you were building an alarm. So they like the idea of flow charts, as you can see. So I think if you remember from the interface design class, we tried to do navigation using the sticky notes. Do you remember that? Where we would draw the different sections on sticky notes and try and put them together. Some of us were in that class a long time ago. So again, a great way to do the UX design and interface design is to think of a flow chart and how people may go through your content so that you're not missing anything in the design. Some of you had some really good final projects in the interface design class, and that was a lot of fun. Making screens and how they go. Again, you can use, we use Sketch or Photoshop or Illustrator, some kind of application, or, there's other applications that are based upon Then they talk a little bit about designing an idea for a pizza delivery app and what would be involved in a pizza delivery app. We don't really need to do that. I can just move on from there. But it might be a good idea to as you go through learning more about app design, thinking about planning. Planning is more important really than actually building, because you really should know what kind of screens you're going to make before you dive right into Xcode and start writing code. They even say that in the chapter here. So, again, making a flow chart and so on. And then, of course, we can do our, let's do the quiz here. Which navigation style does the Apple map use? The email. Flat design, right? Dope. Hierarchical design, right? Dope. There we go. Okay, that's the second one. What navigation style does settings app use? Well, I guessed wrong the first time, so somebody else tell me. Hierarchical. Very good. What navigation style does the music app use? Flat design, right? There we go. Because it has the tab menu at the bottom, right? I'm just basically going through. Which navigation style does most game apps use? And we just talked about that already. That would be the content driven. There we go. Okay, let's move on. Okay, so again, mostly this week we're going to be using, we're going to be going through lesson 10.3.10, which is basically a personality quiz. Kind of like at the end of chapter 2, we had our big app that we did with the hangman kind of game, right? Well, this is the big one at the end of chapter 3. It's going to take us maybe a couple classes here to get through everything, but I did about half of it. I didn't do the whole thing, so we'll have to finish it together. One of the nice things, like I said, is that it goes over the auto layout, which I think we need to all practice our auto layout. I know we all struggle with that. I still struggle with that. In addition, it talks about going from screen to screen, so it practices the view controllers, right? Going from data to data and so on. So it's a good kind of example to get us practicing some of the things that were done in this chapter. Okay. You guys ready? Okay, let's go dive right into it. Again, this is called the guided project. It's called a personality quiz. Basically, it's kind of like question and answer, and then if you choose certain answers, it'll give you a result. Hey, you might be, and it gives you emojis. They love using emojis. You might be a bear personality or a cow personality, or I don't know, something like that. So it's kind of a quiz kind of show kind of thing where you choose multiple answers to a question, and depending upon the multiple answers you choose, will then give you a result. If that makes any sense. So let's continue here. So again, this is 3.10. In this unit, you'll learn about the UI kit framework and its controls. You also learn how to manage position and size of views and controls using auto layout and stack view. Again, that's what we always need to practice, that kind of stuff. While managing the flow of your app using navigation and tab controllers, now you combine all the knowledge to build an app. For this guided project, you'll create a personality quiz. Maybe you've seen this type of game before. Players are presented with light-hearted topics and answer questions that align them with particular outcomes. Here are some examples of personality quiz topics. What animal are you? What country should you visit next? Which Apple product are you? And of course, it's all based upon Apple. We can change that kind of stuff and make it, something different. Right? It doesn't have to be what Apple product are you. It's their book. Hey, they can do whatever they want. But we could be, what flower are you? How about that? Or what? I don't know. I like flowers. It's spring flower. Mother's Day's coming, right? I should order my Mother's Day flowers soon. In fact, it was my mother's birthday on Saturday. There are no correct answers to the quiz questions. Answers are purely subjective, and the results don't even have to be logical. For example, suppose you design a quiz called "What country should you visit next?" You could pose the question, "What is your favorite color?" and decide the answer green aligns with Italy, not France. Other questions and answers might make more sense. The player prefers sushi over pasta. You could award points for Japan instead of Italy. Okay, so again, it's asking questions and having the user choose multiple results, and then coming up with, hey, your favorite color is blue, something like that. We all did that. That was kind of like your matchmaking. Remember that? Anybody have matchmaking? And I remember in high school, when I was in middle school, I remember I manipulated. I liked the one girl, and I stole her answers, and I put in the same answers, and of course we came up the same. Okay. It was done on a computer. Rather than driving directly into Interface Builder or Swift, it's important to think about the goals and requirements of your personality quiz. Who is your target audience? Maybe you have a topic in mind. What features would the quiz include? What models of user would be needed and accomplish those features? I think the number one thing would be, who is your audience? What age group, right? If I'm going to make a personality quiz for teenagers, it might be different than adults, might be different than kids, right? So, and of course, the questions you might ask, for kids, it might be very, kiddie kind of questions. For adults, it might be more adult-like questions. So that's kind of I think the more important thing is not necessarily design, but more who is the audience. If you try digging right into code, and here's what I was talking about. They say, hey, don't dig right into code. Plan a little bit ahead of time, right? What features are required to produce a fun personality quiz? Since it's probably your first app of this type, keeping a short list, a minimum the app should accomplish is the main three goals. Introduce the player to the quiz, present questions and answers, and display the results. How about that? With those three goals in mind, try to imagine an app as a series of related views. Each feature is distinctive from the other two, so each deserves its own screen. Some type of input would be move the player from one feature to the next. For example, you can include a begin quiz button to move the player from the introduction to the questions and answer the final questions and translate a displaying the results. For the purpose of this project, you need at least 3 view controllers, one to present each of the 3 features. Of course, they're only asking 3 questions in the whole thing. You've already saw that. What animal are you? What was it? What animal, what country, and what Apple product. So at least 3 views, probably more. Did you also think about presenting a new view controller for each question? That's not actually necessary. In early lessons, you learned about 2 methods of presenting view controllers, modelly or with a push into a navigation stack. The modelly present screens typically include a way to be dismissed, and any new view controller, you push a navigation controller as a back button in the upper left corner. In either case, there's always an implied method of dismissal. So they're just talking about you have multiple screens. Depending upon what navigation you can use will depend upon maybe how the displays of different views are. What would happen if you separate view controllers for each question? Imagine a player is on the 9th question and wants to return to the 3rd question. If you have a view controller for every question, that would have to be dismissed 6 times controllers to go back. That's okay, but then you'll have to answer the questions in between all over again to return to the 9th question. In this project, you'll update a single screen that presents all your questions rather than presenting questions as separate screens. It's just basically changing the content. Every UI view controller subclass you create is in fact a controller. A view controller uses the data model you've defined to control the view that displays on the screen. As your app grows in complexity, you will create additional controllers to manage the model data, freeing up the view controllers to focus on a view-related code. However, since this personality quiz has just 3 screens that contain very simple content, your view controllers can handle and manage that data. So again, it's pretty simple. There's only a few questions. Depending on your quiz topics, the questions you want to ask, your personality quiz may need different input controls. Consider the following questions. Which food do you like the most? Okay, and so one way you could do this is almost, if you think back to web design, where you could have maybe radio buttons for certain things, or maybe check boxes for certain things, or switches, right? Remember we looked at a switch before that has an on-off, right? So maybe if they're choosing a certain series of things, you could just use a switch for that, or a checkbox or something like that. The first question is multiple choice options where only one answer is valid. For this question, you could use a button for each food. The second question can have 0 or more answers. You could use switches so that the player can select many foods. Just like, I guess my whole point there is radio button would be the first one, right? In web design, I'm trying to relate it to web design, which you've all probably taken at least a HTML class. And then the second one would be the checkboxes, right? But we call them switches mostly here. And the third question might involve 1 to 10 scale using a slider. That might be interesting. You know, I've used sliders for volume control mostly. Hey, you want to turn the volume up and down. As you can see, the types of questions dictates the controls that are displayed on the screen with a single view controller for all questions, and so on. Here, we can put that on what I'm reading there. For a single view, multiple answers range fine. What type of data do you need for a personality quiz? At first, you might consider creating an array of strings to hold your questions, but where would you store the answers? A better idea would be to create a question struct that holds a collection of answers. The collections of answers also need to be more than just an array of strings because each answer will correspond to one of the quiz's outcomes. At the very least, you'll want to include a question struct, an answer struct, and some sort of result type. Consider result type in personality quiz. An answer can correspond to any one outcome. For example, in the animal quiz, the results will never be a dog and cat. It will be one or the other. In this perfect use case for enumerations, in the same way that a direction enumeration might have north, south, east, and west case, the animal type can be dog, cat, rabbit, or turtle. If you've forgotten the details of using enums, take a look at the enumeration lesson in lesson unit 2. And I think we looked at that briefly. It's kind of like a case, you know, where you if this, then that, if that, then that, without using the if statement. Right? Using the case statement, but it's kind of similar in concept. Now that you've analyzed which components you need, it's probably easier to see how the project will come together. You'll use 3 view controllers for your quiz. First is an introduction screen with information about the quiz and a button to begin. As you can see, second view controller displays a question and several answers and manages the responses. This view controller is refreshed for each question and depends on what kind of question you ask. The right controls may be displayed. Again, we already talked about that. And the third view controller tallies up the answers and presents the final outcome. The results can be dismissed, allowing another player to start the quiz from the first view controller. Again, they have emojis in there. You can see the little drawing that they have there. You got emojis in the corner. And we saw how to get the emojis in Xcode. I think it was under Edit, right? I think it was under Edit. So part 2, project setup. Create a new project, single view application template, name it personality quiz, and open a main storyboard. So again, we can start. I can put which side you want the computer on. The computer over there, and then reading on this. Oh no, wrong way. That's. Or I can put the computer on both. I don't know. You might want to see. Okay, so again, I'm going to start right now. Again, as far as graphic-wise, they just use emojis. If you want, you can make your own graphics as well. I don't know. You might want to use photos in your example instead of emojis. It's fine. But again, you would have to then start thinking about how to use the photo. The emoji's pretty built into the iOS. Again, I'm just going to start Xcode here. And we're going to start with a new Xcode project. It's going to be a single view, and they call it, of course, personality quiz. So single view right there. Hit next. And we're going to call personality, personality quiz, like that. And then we're going to hit next. Find a place for your app to go on your computer. And then the first thing we're going to do is go straight to the view controller. So go straight to the main storyboard, the main storyboard. You'll need 2 more. Drag 2 view controllers from the object library onto the canvas and position all 3 in a horizontal view. again, right now we only have one view controller, and of course you have one view controller, but you also have one Swift file, right? So most likely we're gonna have to make multiple Swift files. So I'm gonna zoom back out, boom, 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 so you can see. So we need to have 3 view controllers. Again, I'm gonna drag another one out next to it. I'm gonna scroll over a little bit, drag another one out. There we go. And let me stop this.